categorical variables. There's three plots that you could most likely see, three types of graphs. When it comes to two variables, the best way for the data to be displayed is going to be with a two-way table. I only point this out because there have been years on the FRQ section where they've gone and they've said, create a two-way table to display the data. And it's simple as rows is one variable, columns is the other. But because of the wording or what it's called, some people kind of freak out and they forget what a two-way table is. All it is just displaying one categorical variable for the rows, one for the columns. In this case, we're looking at data from the 2020 election. And so we have the two political parties and we have the regions of the United States. And so what you'll notice is it does total up to all 50 states. So they divided them into Northeast, Midwest, South, and West. Now the most, you see it sometimes, but it's not the most popular type of graph, is just a side-by-side bar graph. And that means every single, and in this case, we're going to be graphing by region. Every single region is going to have two bars. One bar is going to represent the total for Democrats. One bar is going to represent the total for Republicans. The highest count that I'm seeing in my table is 12. So that is the highest frequency I have on my graph. Now, when it comes to the x-axis with categorical variables, the order you put them in does not matter. So you can do alpha order, you can do table order, you can do whatever order you want. And that's one of the big reasons why we're unable to go in and say this distribution is unimodal or it is symmetric or skewed to the right or skewed to the left, because you have the ability to change the order those bars are written in. So you can change the shape of the distribution. So it wouldn't really make sense. For the Midwest, or let's start with the Northeast, I'm going to kind of look at my table on the side. It looks like there were 9 states that voted Democrat. Now, I know you most likely only have a pencil. So if you have a pencil only, one of the bars could be shaded in, one could be not shaded in. As long as you have some distinguishing feature that shows one bar versus the other. I have colors, so I'm just going to use Democrat. We'll keep it to the party colors. It's going to be blue. I did get the question of, when we were doing histograms, do I have to color in every single bar? You do not. Now, if I only had a pencil and I had multiple different types of categories, I may go in and do one is striped and one is dotted and one is solid and one is blank. Whatever pattern you create, just make sure that you have somewhere on there a key indicating what is what. So in this case, I have Democrats at 9. There were no Republicans in the Northeast, no Republican states. So I'm just going to go ahead and label this Northeast. And then it's the same kind of reasoning with a regular bar graph, where if you have a certain width for a bar, use it consistently. So I have 1 unit wide for Northeast. So I would have had a Republican bar next to it. So I'm going to kind of skip an extra one so that I can start with the Midwest, which had 4 Democrat states. Now, I know we harped on your bars cannot touch for categorical data because that's what a histogram does. But in the case of side by side, a lot of the time you'll see the bars grouped together and they're touching. So if it's 2 variable data, it's okay. If it's 1 variable data, you most likely have the space to spread everything out. So don't keep everything super close. Now for the Republicans, there were 8. So I'm going to go up to the 8. And hopefully none of this is brand new information. The next 2, you've for sure seen one before, but the other one may be entirely new to you. But a side-by-side bar graph, you've probably seen on your biology star tests, your history star tests, for sure, because they love graphs on state testing. I don't know if I unlocked the door. Nope, it's not. Okay. With a graph like this, there isn't much that you can say specifically in terms of what we talk about for quantitative data in terms of stocks. However, if they ask you to describe this distribution, what you can kind of talk about is key features. So you can say that like anything that seems interesting, like the Northeast had all Democratic states, whereas the other regions have some Democrat, some Republican. You can talk about how the South, the one I'm about to draw, has the most Republican states. You can talk about how the South and the Midwest both have the same amount of Democrat states. Usually, if this is one of the questions on the FRQ, they kind of just have like a requirement of, did they talk about 3 or 4 things? Now, unless they ask you specific questions in terms of like, which one is higher, which one is lower, all they're looking for is kind of bullet points as to what you're looking at. Now, typically the best kind of approach is talk about the highest values and talk about the lowest values. Talk about anything where they're the same or where they're drastically different. But usually for these, it's kind of open-ended because you can kind of discuss a bunch of different things. When it comes to the last one, I have the West has 8. Let me draw this, and the Republicans are 5. So if you ever see these, typically they're going to be in frequencies, meaning it's just going to be counts. It's not going to be actual percentages, which is what we're going to look at in the next type of graph. But a couple of things just to make note of. Make sure that you scale the y-axis. And if they give this to you, pay attention to the scale. Because sometimes it's in frequency, sometimes it's in relative frequency, sometimes it's not in a 1, 2, 3, 4, 5 scale. They do like 5, 10, 15, 20. So pay attention to the values that they're giving you so that you can make sure you're talking about all the data correctly. So I have my South, I have my West, and then we have our Republican Party. You write my key. And so for the rest of the graphs, I'm going to go in and I'm going to use this kind of model as what we're going to follow. If they don't indicate like what they want the x-axis variable to be, that's kind of your choice. I picked the regions as my x-axis variable so that each one could have 2 bars, but I could have picked political party. And then each political party would have 4 bars because they'd have 4 regions for Democrats, 4 regions for Republicans. If you have to draw this yourself, make sure you draw them in the same order. So if you drew the Democrat bar first, draw the Democrat bar first consistently. But again, side by side. Now, the most popular one, for sure, 100%, you will guarantee to see at least one of these, is going to be our segmented bar graph. Now, you have seen this before. You've seen a bar graph where it's kind of stacked and it's divided into different subsections. That is representing data from a two-way table. For the most part, I try to organize something that's going to show, like help me figure out what percentages I'm going to have. I'm following the same model as what we did in the previous one where region is on my x-axis. So I'm going to have 4 bars and each bar is going to have 2 sections, 2 segments. One will be for the Democrats, one will be for the Republicans. So one important thing about this is make sure if you're stacking them, you stack them in order. So I have my Democrats, I have my Republicans. I'm going to start with the Northeast just because it's the first one. In the Northeast, there are 9 states total. And for the Democrat states, there's 9 of them. So this bar is actually going to be 100% Democrat. So all blue in this case. I'm going to run down the list. For the Midwest, there are 12 states total, and 4 of them are Democrats. So that's about 33%. For the South, 4 out of 16. That's 25%. And I'm just getting this information from the table at the top of the page. 8 out of 13 is going to be about 62%. Now, one thing about this, notice that I am rounding to whole numbers. It's because I'm going to kind of estimate where these values are anyway. You'll notice my y-axis is scaled by tens. That's because in these types of graphs, every bar should end up being the same height in the end. They should all be 100% tall, and that's how tall it's going to be. So in the case of my first group, my Northeast, for my 100, they are going to be all blue. Typically, these bars end up being a little bit wider than what you would do for a side-by-side. Christian, can you close your computer for me, please? Thank you. So they end up being a little bit wider. I'm just going to go 2 cells wide because it covered the 2 bars that I have. And we will stack them in the same order. So I'm going to do all the Democrats first. So I have about 33%. So I'm going to go where I think 33 is. And that's why it's not super important that you round to like 2 decimal places like we do in everything else, because you're kind of just eyeballing it either way. And then we have 25% for the South and 62% for the West. Oops. Now, one thing about this, whenever I take this data and I turn it into relative frequencies, which is just a percentage, that's all. It's a fancy word for saying I'm finding the percentage. I kind of lose the ability to talk numbers. So you will get questions, I can guarantee, where they're going to give you a segmented bar graph, and it's going to be one of those things where they say, which of the following is true? And there's 4 statements. And they're like, there's more Democrats in the South than in the West. And they'll have all these claims that you're supposed to check and see in the end which one is true and which one, all the rest would be false, or vice versa. But you cannot talk numbers. So in the segments that I have currently, I just know percentage-wise how many states in that particular region ended up voting Democrat. I don't know specific numbers. I know the percent of people in the North, or states in the Northeast, that voted Democrat is higher than the percent of states in the South, but I don't know specific numbers. So any answer choice that you get that says the number of states, just using this example, in the Northeast that voted Democrat is higher than the number of states in the West that voted Democrat, even though it may be true. Like if you had gone back and looked at the data and it was true, if you had the graph only, you can't come to that conclusion. So if they say anything number-wise, you can't agree with it because we don't know how many people were sampled in each of the categorical variables. So I have my 4 bars. Now the next part, because there's only 2 regions, I don't necessarily have to calculate the Republican side of things, simply because I know in total each of these bars should represent 100% of the data. And so when I come in, the height should go all the way to 100%. Now, this is because I only have 2 of them, but if I had to calculate multiple, I would just go in and find the percentages. So 0%, 8 out of 12, 67%, 8 out of 16, 75%, and 5 out of 13, 38%. But doing that gives me my second segment. Now, if I had multiple segments instead of just 2, maybe 3 or 4, I would just keep stacking until all 4 were there and I made it to 100%. So I'm going to have Northeast, Midwest, South, and West. Now, with this, just to kind of make some notes, because again, this is probably the one that you're going to see the most. It's going to be the most popular in all of the stats graphs that you get. I'm going to draw a little note up here. If the bars are varying heights, then that means there's an association. Oops. What that means, they're going to have questions that say, is there an association between political party and region of the United States? And they're asking, is there a relationship between these 2 things? Now, the reason why varying heights indicates this, that's because if I were to pick, so it's kind of like a conditional statement, if I pick a state in the Northeast, my chances of selecting a Democrat state is 100%. However, if I pick a state in the South, my chances of selecting a Democrat state is 25%. So because those numbers are different, because the chance of selecting your region first drastically changes your chances of getting a Democrat state overall, that means there's an association between those two variables. And to kind of build on that a little bit, if you were going to see a bar graph and all of the bars looked not exactly the same, but they're pretty close to each other, like it doesn't make a huge difference whether you pick bar 1 or bar 2, then this would be there is no association. So if you look at a segmented bar graph and they're all about the same height, there's no association between those two categorical variables. If you look at them and they have varying heights, and it doesn't have to be like all of them are different. If one is different from the rest, we say that there's an association because that one bar that you're looking at is going to change your overall chance of selecting, in this case, a political party. So segmented bar graphs, make sure that you're very careful. If it's varying, there's association. If it's not varying, there is no association. The other note that I like to make is you can't talk numbers. All we can talk is percentages. So from looking at this segmented bar graph alone, I could look at it and say, oh, there are more states in the South that voted Republican than there are in the Midwest, just because that bar looks to be bigger. However, if you look at the counts for the Republicans in the South and the Midwest, it's the same number. So that's what I mean by you can't talk numbers from a segmented bar graph. You can talk percentages, but you can't say exact counts are different from this. Okay, now the new thing. With this, I call it the new thing because prior to the 2021 exam, so in 2020, they put mosaic plots into the curriculum and they wanted you to graph it. And then the 2020 tests got a little weird. They had to adapt and change it. And so 2021 came and we saw mosaic plots for the first time. Now, a mosaic plot gives us the same data that a segmented bar graph does. However, it gives us the ability to talk numbers. So the first thing that we have to do, what's going to happen is in the segmented bar graph, all the bars were the same width. What the mosaic plot does is it takes up space depending on how many people are in each individual sample. So in this case, the Northeast, they had 9 states out of 50. So I would go in, I would take 9, I'd divide it by 50. That's about 18%. So 18% of my x-axis should be taken up by the Northeast bar. So I go down the list, I find all of the counts. The Midwest was 12 out of 50, which is 24%. The South was 16 states out of 50, which is 32%. And the West was 13 out of 50, which is 26%. So what's going to happen, and you don't have to scale the x-axis like I'm about to, we're going to take the x-axis and split it up into percentages. So I'm going to go ahead and just label it in the exact same way I did the y-axis by tens all the way up to 100. And everywhere I kind of hit one of those markers from my bar graphs, so 18, 26, or 24, 32, and 26, I'm going to draw my bar. So my first one should only be 18% wide. So I'm going to go a little less than 20. And if you kind of get stuck putting these next to each other, I always say go in and add as you go. So this is almost like a cumulative relative frequency. So if I start with 18% and I add in that 24%, I'm going to get 42%. And so that means my next line is going to be somewhere at 42. And what you'll notice is these bars start to take up different amounts of space. And so what we can do with this is we can start talking area. If a certain segment has more area than another, it has more people, places, or things sampled within it. So I have 42, the next marker would be 74, and that should take us all the way up to 100%. So I'm going to go to 74, and then I have my 100%. And what you'll notice is the one that takes up the most space currently is the South, which makes sense because it has the most states in that sample. Now, what we're going to do with this is we're literally going to take the places that we segmented our bar graphs in the segmented bar graph, and we're going to draw them down here. So for instance, the Democrats, it was a full 9 out of 9 Northeast Democrat states. So this entire first bar should be all Democrats. And then we jump to the Midwest. The Midwest had a 33-67 split. So I'm going to kind of go to the 33 mark, and that's where I'm going to start my Republican section. So I'm literally taking the segments from the previous graph and I'm just copying them down here. So all of the data we found for the segmented bar graph is just transferring over. So here's my 33% mark. That's going to be the Democrats in the Midwest. For the South, it was about 25%. So I'm going to go in, do 25. Now, when you actually look at these on questions on the AP exam, they are colored much more nicely than mine are. So you can actually look comparatively in terms of area. For the last one in the West, there were 62% that were Democrat. So I'm going to go up to the 62 mark and draw my Democrat line. So if you go in and you compare your segmented bar graph to your mosaic plot, they should look almost identical. The only difference is instead of having bars that are the same width, your bars will have widths dependent on how many people are sampled for each variable. So if I compare this to what I have up here, the heights, and I'm going to kind of zoom out so you can see them together, the heights of the bars are the same. So like it is still segmented in exactly the same way. The only difference is now with the mosaic plot, it takes up the entire x-axis. So if you look at a graph and you notice like, wow, that's a big square, it's all colored in, that's a mosaic plot. And all you have to do is go in and say area-wise, if I look at the South and I compare it to the Midwest or the West, I can see that the area of the South is larger than the area of the West. So I can say that there are more states that are Republican in the South than there are in the West. This is one that kind of gives you that ability to go back and talk numbers. Because if the area is larger, there's more counts within it. We still got a label, so I'm going to go in Northeast, Midwest, South, West. I do still need a key. I know I didn't do one on the one before, but you do need one. Republican, Democrat, and realistically, kind of giving you a good expectation, you're not going to have to make 3 of the same graph. Truthfully, you may not even make one. Yeah, you may make one, but a lot of what they're going to do is give this to you and ask you questions about it. I like for you to actually make them yourself so that you can kind of see how is this data calculated? Where are these percentages coming from? Because I can tell you up and down how to read this for days, and it still usually doesn't make sense until you actually try making it on your own. Now, one thing, if you get a question like this on the FRQ, they don't require that you make a table. They really just want the graph only. I do think the tables are sometimes helpful just so you can kind of organize your information, but you don't have to have a table for a question like this. They just want the graph only. So if you want to do all the calculations in your calculator, transfer them over to the graph, totally fine. Now, to kind of switch gears just a little bit, to kind of go more into what we can do with that two-way table, a lot of this that we're going to talk about next is very surface level. We will eventually get to our probability unit. That's unit 4. I think we start it like right after Thanksgiving, so right before we leave for Christmas break. And that's all probability. So this is kind of like very surface level. If you see a table and they ask you to find these frequencies, this is how you should do it. A relative frequency, again, is only a percentage. So if you find the relative frequency of this, it's just find the percentage of this happening. Now, there are 3, and I'm going to kind of talk about them more in the context of the question. We have the joint relative frequency, and that is going to be us going in and taking a single cell over the table total. And typically for joint relative frequencies, you'll see the word and or but. So what is the probability of selecting a Democrat state, but they're from the South? So both of those things happening at the same time. So in our case, they said, what is the percent of states that are in the Midwest and voted Democrat? So all I have to do is go look for that cell where both of those things are true, and I'm going to take 4 over 50, and that's going to give me 16%. So that is a joint relative frequency. A marginal relative frequency is going to be a row or column total. Oh, it's 50. Yep, it's 8. Sorry. I tried to quadruple it. Thank you. It's Monday. 8%. I promise I got it right all 3 times on Friday. For marginal relative frequency, it's a row column total over a table total. This one, I will say, is one of the highly, highly missed problems kind of across the board, because they will ask the question, what is the marginal relative frequency of the South? And then people kind of panic and they freak out and they're like, what the heck is a marginal relative frequency? In the same way they freak out of what is a two-way table. All they want you to do is see what is the chance of selecting someone from this region only. So in our case, from the South, that is going to be 16 out of the 50 states, and that's 32%. So anytime you see marginal, that just means row, column. And then your most popular one is our conditional relative frequency. And as it probably makes sense with the name, it gives you kind of a condition that you have to meet first. So we are going to look at a specific cell, but instead of being over the table total, it's going to be over a row or column total. So in this case, our condition is of the states that voted Democrat. So instead of looking at all 50 states, we want to look at the 25 that voted Democrat. Of the states that voted Democrat, the percent that is from the West. So there are 8 states of the 25 that were from the West. This is where my multiply by 4 came from. So this is 32%. 4 quarters make $1. So the hardest part about this one is knowing which part is the condition. Pay attention to the wording of the question. If you do this, then what's the probability of this? Or given that you selected a Republican state, what is the probability they're from the South? It will kind of, and it's not, sometimes they'll switch it up and they'll put the condition after, or like in this case, what is the percentage of selecting a state from the West if you picked a Democrat state? So I get a lot of people who get stuck in the habit of picking the first thing that they say and making that the condition. It's not always the case. Pay attention to kind of what language they're using and showing you like what subgroup am I focusing on. Okay, two-way tables, percentages, easy peasy. And truly, you don't have to think about them too hard. The only thing I would know vocab-wise is joint, marginal, and conditional, just in case it pops up in a question. All of this, I'm sure you are more than capable of doing, just reading a table for 10 years of your life, probably since 3rd grade. The next question. This is mostly because there is some notation that we do use in stats that kind of might be new to somebody, might not be. One thing I can tell you, if you were in Algebra 2, you probably know what this symbol is. This symbol was the union symbol. We used it for domain, we used it for range, we used it when we were writing answers in interval notation. Basically, this symbol stood for OR. And then, not something that we use in Algebra 2, but kind of the complement of this. If you kind of draw it in the other direction, this was our AND. So this is kind of what we're going to focus on today. We will eventually in Unit 4 get to use the OR a whole lot more. I kind of don't like, on the AP exam, you don't have to use the symbols. I only show it to you because if they present a question to you using symbols, I want you to know what they're saying. But if you're like writing your answer and you're like, oh my gosh, I don't know if it's the up U or the down U, like you can write the word and you can write the word or. They're not going to take off for you actually writing it out in the same way they wouldn't take it off if you wrote sample mean instead of X bar. So this is mostly just exposure for if you see it, you know what they're saying, but you don't have to do it this way. So in this particular problem, we have two kind of things that are happening, two variables. Did 100 students complete the most popular health science program? And then did they go on and complete more advanced studies? So a lot of what College Board will do is they'll kind of try to shorthand things. So we're going to go in and we're going to kind of shorthand this. I'm going to call completing more advanced studies event A. And it is, again, I kind of said this in my Algebra 2 class when we're learning set notation. It's a mathematician's way of being lazy. Like they don't want to write this every single time. So we'll just call this event A. Now, the symbols that they use in stats for the complement, the no, is A with a little superscript C. So that stands for A complement. Some of you in calculus may kind of be, or have had calculus or in calculus, may be kind of familiar with something similar. Sometimes it's a little apostrophe, like A prime is kind of like the same thing as not A. This is what they use in stats. So AC, I'm just going to write it out, stands for A complement, which is the same thing as saying not A. And again, you don't have to use this. You can literally say not A, or you can say did not complete more advanced studies. You can write it out in words. It's just in the event that you potentially see it because they gave it to you. So A complement is not A. I'm going to call completed the program B and did not complete the program B complement. So we're just going to practice what this would be if we had a question. Now, I gave you the words. They potentially, because we've seen problems like this before, may only give you symbols. And so we're going to kind of write out what the symbols would be just in case you happen to see it. So in the first problem, they say being a person who completed more advanced studies is more likely than being a person who did not complete more advanced studies. So in this case, I'm looking and I'm comparing completed more advanced studies, which is A, and I'm trying to see, is it more likely than being a person who did not complete more advanced studies, A complement. So what they could do instead of giving you the words, they may say, is the following statement true? And they will just give you this symbol. Now they would go in and have to identify A is this and B is this, but we've seen it before where they've given you just the symbol notation and they've asked you to verify it's true or false or compare it to other things. In this case, the number of people who completed more advanced studies is 40. And the number of people who did not is 60. So this is a false statement. And I know it seems pretty straightforward, but the complicated part of a question like this is they would only give you the symbols. So yes, very realistically, you could go in and just look at the question and be like, yeah, 40 is bigger than 60. But you have to know what the symbols themselves mean. Again, not super popular question, but has shown up before. So for part B, we have being a person who did not complete the program. Oops, let's highlight. Did not complete the program. And then there's my kind of joint relative frequency word of but. So that means both of these things have to happen together. So that's my and almost. But completed more advanced studies is less likely than being a person who completed the program and completed the more advanced studies. So kind of breaking this down a little bit into pieces. Being a person who did not complete the program. So that was B complement, but completed more advanced studies. So that was A, is less likely than being a person who completed the program, which is B, and completed more advanced studies. That's A. So again, I gave you the words, but they could very well just give you the symbols and ask you to verify, is it true? So if I look at my table, my B complement and my A together, that's the singular intersection of those two events. That is going to be, there's 5 people total in that intersection. This is a joint frequency. And then if I look at the intersection of B and A, there are 35 people who did that. So in this case, we ended up stumbling upon our true statement. 35 is bigger than 5. And for the last one, we have being a person who completed the program, but, which again kind of functions as our and, did not complete more advanced studies, is more likely than being a person who did not complete the program and did not complete more advanced studies. So completed the program is B. So I know my first statement is B, and did not complete more is A complement. More likely did not complete the program and did not complete more advanced studies. So all you have to kind of take if you were given this question is take it piece by piece. This is completed the program. This is no more advanced studies. And means they have to happen together. In my counts, I have 25 people who fall into the first category, and I have 35 people who fall into the second. In this case, this is another false statement. Now, I did get the question, do I have to do it this way? Do I have to write the symbols? No, you do not. You can write out the words. Now, the words are a lot if you wanted to write it out. If I was trying to display these events, I would literally be writing all of the words that are in the question. So it sometimes is nice, especially if you don't want to go through the trouble of writing it out, but it's not required. If you want to identify these as events and use that instead, you can, but you don't have to. Now, for the last example, I have literally done all of it in the examples we've done so far. Will anyone be heartbroken if we skip over the final example? No. Okay. So I'm going to open your Pearson assignment. It will be due on Wednesday. I have to double check. I don't think your Unit 2 test is for like 2 weeks. So not next week. I think it's the following week after that. So we have some time between now and test day.